M.S. Ramaiah University of Applied Sciences.
Hi students, let us have a discussion on relationships between phase and line currents and voltages in a three-phase system, star and delta. The objectives of this laboratory experiment are to verify the relationship between phase voltage and line voltage in a three-phase system using star-connected load, phase current and line current in a three-phase system using delta-connected load. Three-phase AC supply is carried by three conductors called R, Y and B. The currents in these conductors are known as line currents IL and the voltage between them are known as line voltages VL. Three-phase systems are connected either in star or in delta. This is the basic three-phase circuit. It consists of three phases. They are named as R phase, Y phase and B phase. The two common methods of connection in a three-phase system, that is star and delta connections, are as shown in figure 2. Figure 3 shows how to measure line voltage and phase voltage in a three-phase system. Definition of line voltage. When you measure voltage between any two phases, RY or YB or BR, it is called line voltage. Definition of phase voltage. When you measure any phase R or Y or B with respect to neutral, it is called phase voltage. Figure 4 shows how to measure line current and phase current in a three-phase system. Definition of line current. When you measure current through any line R or Y or B, it is called line current. Definition of phase current. When you measure current through any phase R or Y or B, it is called phase current. In a star connected system, VL is equal to square root of 3 VPH. IL is equal to IPH. In a delta connected system, VL is equal to VPH. IL is equal to square root of 3 IPH, where VL is equal to line voltage, VPH is equal to phase voltage, IL is equal to line current and IPH is phase current. This is the experimental setup of three-phase star-connected load. This is the experimental setup of three-phase delta-connected load. Discussion. Verify relationship between line voltage and phase voltage in a three-phase system using star-connected load. Verify relationship between line current and phase current in a three-phase system using delta-connected load. Comment on your results. Applications. In power transmission, star-connected system is used. In power distribution and industries, delta-connected system is used.
Hi students, let us have a discussion on relationship between line and phase currents and voltages in a three-phase system using star and delta connection. The main objective of these experiments are to verify phase voltage and line voltage relationship in a three-phase system using star connection, and also to verify phase current and line current in a three-phase system using delta connection. To conduct these experiments, we need one three-phase variac, one three-phase resistive load, two voltmeters and two ammeters and connecting wires. Let us discuss about the required components related to this experiment. This is the three-phase variac. It is also called as the three-phase auto transformer. It consists of three input terminals, that is R phase, Y phase, B phase, and it also consists of the 3 output terminals. So they are R phase, Y phase and B phase. Usually the input terminals are connected to the supply and output terminals you have to connect to the load through the meters, and this is the variable knob to apply the required voltage. This is the 3-phase resistive load. So it consists of the 3 phases. So they are nothing but R phase, Y phase and B phase. So here the load is completely divided into the 3 parts. So and each part is consists of R, Y, B, and this is the neutral of R phase and neutral of Y phase and neutral of B phase. Similarly, the second part is also consists of R, Y, B, and all the black terminals are the neutral terminals. And similarly, the third part is also consists of R, Y, B, and similarly neutral of R, Y and B. And these 3 are the corresponding load switches to make on and off. These are the 3 fuses related to the 3 phase, and this is the neutral of the 3 phase terminal. These are the 2 voltmeters to verify the voltage relationship in star connection, and these are used to measure the voltage. And here we need 0 to 600 volts AC voltmeter and 0 to 300 volts AC voltmeter, and this 0 to 600 volts AC voltmeter is used to measure the line voltage, and 0 to 300 volts AC voltmeter is used to measure the phase voltage. These 2 are the terminals to make the connections. So we need 2 ammeters to verify the phase current and line current relationship in a 3-phase delta connection, and here these 2 AC ammeters are used to measure the current, and these are the 2 terminals to make the connections. The ranges of 2 ammeters are 0 to 5 amperes. Let us start the connections to verify the voltage relationship in a 3-phase system using star connection. Let us start the connections. So here the input of the 3-phase variac, it is already connected to the supply. Now we have to connect the output of the transformer to the load. So here, so just we have to follow the color notation. That means the output of R phase, it is connected to the R phase of the load, that is R. So here this is the R phase connection. So the output of the R is connected to the R phase of the load. In similar way, the output of the Y phase connection is connected to the Y phase of the load. So this is the Y phase connection, and output of the blue phase connection connected to the blue phase of the load, that is B to B. So just here you have to follow the color notation. So just to make the connection from R to R, next Y to Y, next B to B. Now we have to make the star connection. So I already told this is the 3-phase resistive load. It consists of the 3 individual loads 1, 2, 3. Here you can connect or you can select any one load to make the star connection. Now I am choosing this is the resistive load to make the star connection. Now we know that in the case of the star connection we have to short all the 3 neutrals, that is we have to short all the 3 black terminals. So here the neutral of R is connected to the neutral of Y, and neutral of Y is connected to the neutral of B. So this is the star connection of the 3-phase load. So all the 3 terminals are shorted here. Now let us take the voltmeter to measure the line voltage. So this voltmeter is consists of the 2 terminals. and connect the connecting wires across these two terminals. Now we can connect these two terminals to R and Y, or Y and B, or across B and R. So now I am connecting across R and Y, and here you have to use 0 to 600 volts AC voltmeter. This is used to measure the line voltage. Now let us take the voltmeter to measure the phase voltage. Now connecting wires across two terminals, and this voltmeter is connected across the load. One is connected to the R phase, another connecting wire is connected to the neutral of the R phase. So this is connected across R and neutral of the R. You can also connect across Y and neutral of the Y, or B and neutral of the B. This voltmeter is used to measure the phase voltage. With this, experimental connections are finished as per the circuit diagram, and before conducting this experiment, make sure that this variac knob should be in the 0 position and the load should be in the switch off position. Let us start the experiment. So first switch on the power supply. Now switch on the 3-phase AC supply. Now switch on the load. Now slowly increase the voltage up to 400 volts by using variable knob of the 3-phase variac. So here you have to apply the 400 volts by seeing the voltmeter. So here the voltmeter is taken as the reference to apply the required voltage. Now note down the readings of line voltage and phase voltage, and this is the line voltage voltmeter. It is showing 400 volts, that is VL is equal to 400 volts, and this is the phase voltage. It is used to measure the phase. Now here it is showing 230 volts. So V phase is equal to 230 volts. With this experiment is finished. Now you can verify the voltage relationship in the case of 3-phase system using star connection, that is VL is equal to root 3 times of the V phase. That means the line voltage is equal to the root 3 times of the phase voltage. So here we have applied the line voltage is 400 volts. So with the applied voltage we got 230 volts as a phase voltage. So that is 400 volts is equal to the root 3 times of the 230 volts. So with this experiment is finished. Let us verify the current relationship in delta connection. To conduct this experiment, we need one AC voltmeter and two AC ammeter. Now let us start the connections for the delta. Now the output of 3-phase variac, that is R phase of the variac, is connected to the R phase of the load through ammeter. Now let us take the ammeter. So one end of the ammeter, it is connected to the R phase of the variac, and the other end is connected to the R phase of the load. And this ammeter is used to measure the line current. Now let us make the connection for for the Y phase, the Y phase of the variac is connected to the Y phase of the load. Similar way, B phase of the variac is connected to the B phase of the load. So, these are the connections of the R phase, Y phase and B phase. The R phase connection is connected to the R load through ammeter. See. And similar way, B phase of the variac is connected to the B phase of the load, and Y phase of the variac is connected to the Y phase of the load. Let us make the delta connection. Let us consider any one load. So, we know that the delta connection, it is also called as the end to end connection. So, this load, it consists of the R, Y, B. This is the neutral of R, neutral of Y and neutral of B. Now, neutral of R is connected to the Y phase, and neutral of Y is connected to the B phase, now neutral of B is connected to the R phase through ammeter. So, let us take the ammeter. Here this neutral of B phase is connected to the ammeter, and ammeter other end is connected to the R phase. And this ammeter is used to measure the phase current. Now, let us take the voltmeter to give the required supply voltage. Now, connect this voltmeter across any two terminals. Now, you can connect this voltmeter across RY, or YB, or BR. Now, I am connecting this voltmeter across R and Y. With this, connections are finished. Switch on the 3-phase AC supply. Now, switch on the 3-phase load. Now, slowly increase the voltage up to 200 volts by seeing the voltmeter. So, this voltmeter is taken as a reference to apply 200 volts. Now, note down the corresponding readings of line current and phase current. So, here line current, it is showing that 1.4 amperes, and phase current is showing almost 0.8 amperes. With this, conduction of experiment is finished. Now, you can verify line current and phase current relationship in a 3-phase system using delta connection. That is, you can show IL is equal to the √3 times of the I phase.
At MSR UAS, we spark your imagination unlike any other.